Welcome back to Intellify. I'm Rasika Ramakrishna and let's continue with the chapter on quadratic equations. Exercise 4.1, question number 1. So in the previous video, we had done 3 subdivisions of the first question and understood what quadratic equations were. So in this video, we'll be doing the next 5 subdivisions of question number 1. So recall that a quadratic equation is an equation of the form ax square plus bx plus c equal to 0, where a, b and c are constants. We can also look at it as a polynomial of degree 2. Alright, so let's look at subdivision 4. We have x minus 3 times 2x plus 1 equal to x times x plus 5, and we have to see if this is a quadratic equation. So, multiplying both the sides, we have 2x square minus 5x minus 3 equal to x square plus 5x. So, here obviously both your x square terms will not cancel out because their coefficients are not the same. So you will have x square minus 10x minus 3 equal to 0. So since this is a polynomial of degree 2 or an equation of the form ax square plus bx plus c equal to 0, it is a quadratic equation. So let's go ahead and look at subdivision 5. So we have 2x minus 1 times x minus 3 equal to x plus 5 times x minus 1. So polynomial multiplication will give you 2x square minus 7x plus 3 equal to x square plus 4x minus 5. So grouping the necessary terms, you'll be left with x square minus 11x plus 8 equal to 0. So since this is a polynomial of degree 2 or an equation of the form ax square plus bx plus c equal to 0, this is definitely a quadratic equation. So let's look at subdivision 6. So here we have x square plus 3x plus 1 equal to x minus 2 the whole square. So we know that a minus b the whole square is nothing but a square minus 2ab plus b square. So using this, we have x square plus 3x plus 1 equal to x square minus 4x plus 4. So on simplifying, we will have 7x minus 3 equal to 0. This is because x square and x square get cancelled. So this is not a polynomial of degree 2. Instead, it is a linear polynomial. Therefore, the above equation is not of the form ax square plus bx plus c equal to 0, which implies it's not a quadratic equation. So let's look at subdivision 7. Here we have x plus 2 the whole cube equal to 2x times x square minus 1. So recall that a plus b the whole cube is nothing but a cube plus b cube plus 3a square b plus 3ab square. So using this identity and polynomial multiplication, we have x cube plus 8 plus x square plus 12x equal to 2x cube minus 2x. So which implies that x cube plus 14x minus 6x square minus 8 is equal to 0. So this is a cubic polynomial and it is not quadratic. That is, the degree of this polynomial is not 2. Therefore, it's not of the form ax square plus bx plus c equal to 0, which implies it's not a quadratic equation. Alright, so let's look at subdivision 8. So here we have x cube minus 4x square minus x plus 1 equal to x minus 2 the whole cube. So recall that a minus b the whole cube is nothing but a cube minus b cube minus 3a square b plus 3ab square. So using this identity and so you don't have any polynomial multiplication, sorry about that. So using this identity, we have x cube minus 4x square minus x plus 1 equal to x cube minus 8 minus 6x square plus 12x. So your x cube and x cube cancel out and you're left with 2x square minus 13x plus 9 equal to 0. So here this is a polynomial of degree 2 again, and it is of the form ax square plus bx plus c equal to 0. Therefore we have a quadratic equation.